indivisibility. Oops. Okay, so we'll start with our sig fig notes. All right, so let's start by actually talking about what that word significant means. So maybe you've heard it in like another setting, like maybe in an English class, anywhere really, like what's a synonym for significant, or what does significant mean? Important. John says important. Yes. I like that. Anybody have another synonym for me? What about like, you know, meaningful, right? I like to think meaningful. Ooh, relevant. That's a really good one, Tony. I like that. Meaningful, relevant. All right. So clearly significant figures matter, right? And so, you know, the whole deal here, guys, is that we need to figure out, oh, Tyler's got to go on to prominent. That is an SAT word right there. That's a very good word. Yeah, I like that too. We need to figure out what numbers in a final answer are going to be significant, okay? Now, you might be saying to me, well, why does this matter in the long run? Well, here's the deal, right? Right now, we're going to talk about just rules for figuring out what digits are significant, okay? But very quickly, we're going to move on to do addition and subtraction, multiplication, and division, okay? And once we get into those kind of mathematical calculations, we have to figure out how many significant figures should I be reporting in my answer. And that is all dependent on what numbers you're starting with, okay? So that's kind of the whole basis here, right? The bigger perspective about significant figures is that things need to be consistent, right? So if I use a graduated cylinder, okay, and it's a very accurate, concise graduated cylinder, right? And then in another laboratory, say like at Springfield High School, they repeat the experiment that I did, but they use a different graduated cylinder, okay? Things need to be reported accurately to reflect how accurate, you know, your lab equipment is, okay? Now, in the grand scheme of things, you're probably going to forget about, oh yeah, this is because we have to be accurate in reporting our data about lab equipment, right? You're just going to have this kind of ingrained in your brains, okay, I need to figure out how many sig figs I have in this number and report my answer accordingly. All right, so let's dive in, guys. Let's talk about the rules. We have 4 kind of rules, and they're pretty specific. We're gonna take a look at a bunch of different examples today, okay? So don't get overwhelmed. I am gonna have you practice this individually after our meet, and then again, we're gonna come back tomorrow and we're gonna reiterate it all over again, okay? So non-zero digits are always significant, all right? So for instance, in my example here, I have 159. If I were asked to report how many sig figs were in that number, I would report 3 because they're all non-zero digits, okay? This seems pretty easy, right? Now all we really have to worry about are the zeros, okay? How do I figure out if a 0 is significant, okay? So we kind of have 3 rules here for zeros. Rule number 2 says zeros between 2 other sig figs are significant, all right? I like to refer to this as the sandwich. All right, it's pretty early in the morning, so let's talk about a breakfast sandwich, okay? If I have a bagel and then I have some bacon and eggs in the bagel, right? Top of the bagel, bottom of the bagel. The eggs and the bacon are significant to the sandwich. It's not the same without them, right? Okay, so those zeros in between 2 sig figs are significant. Now, let's take it a step further. I have this number here, 403. But let me be a little obnoxious, if I may, and write down something like this, guys. All right, this number right here, because every 0 is sandwiched between 5 and 9, every 0 here is significant, okay? So if I were asked how many sig figs I would find here, I would report 1, 2, 3, 4, 5, 6, 7, this number has 7 sig figs because those zeros are sandwiched. Okay? All right, not too tricky yet, right? Here's where things get tricky when we start throwing in decimal places, okay? Trailing zeros to the right of a decimal point are significant, okay? So to the right of a decimal point are significant, okay? So let's take a look at this first example. I have 2,870.0, okay? So because this 0 here, let me blow this up a little bit. Because this 0 here is to the right of a decimal point, it is significant. Does anybody want to try and tell me, and it's okay if you're not right, okay? We just started learning this. Why is this 0 here that I'm underlining or arrowing in brown, why is that one significant? John, you want to give it a shot? It's sandwiched, okay? So you might be saying, well, it has to be sandwiched between 2 sig figs. Okay, it is though, because this 0 here is significant, and this 7 is significant because it's a non-zero digit. So we've got a sandwich situation with the 0, okay? So we would say 5 sig figs in this number. Now, same deal with this second number here. This one's a little easier to see, right? Because you're just going to count up 1, 2, 3, 4 sig figs for sure. And then you take a look at the 0, it's to the right of the decimal. Anything to the right of that decimal, he's going to be significant. So I check him off. All right, so both of those numbers there have 5 sig figs. Okay, so space holding zeros are not significant. Rule number 4. Space holding zeros are not significant. Now, a lot of my students struggle with this idea of, well, what are space holding zeros exactly, right? Space holding zeros, I like to think of them as the zeros that would go away if you were to write a number in scientific notation. All right, now, I know that some of you probably are working with scientific notation often in math. Some of you might not have worked with it. We're going to do a refresher on scientific notation tomorrow because we're going to start working with it often. But if you take a look at this number here, I could rewrite this number as 9.3 times 10 to the 1, 2, 3 to the negative third. All right. I was able to get rid of the zeros and give the same exact number. I didn't cut anything out. I didn't change anything. It's the same exact number. So those zeros qualify as space holding zeros. All right. Now let's look at our other number here, 9,300. If I were to write that in scientific notation, I would write 9.3 times 10 to the 1, 2, 3. Okay, so again, those 2 zeros, I was able to get rid of them. They are space holding, place holding zeros. You can kind of apply the other rules here too, guys. These zeros right here are not sandwiched. They have the top of the bread, but they don't have the bottom of the bread, right? They have nothing to the right of them to sandwich them in. All right, they're also not trailing a decimal point, okay? In this first example, because we have that decimal point there, we kind of have to use the space holding rule over that trailing the decimal point, okay? I like to kind of add in, not really another rule, but just kind of a really good instance. So we looked at this number here, this 0.0093. What if I did this to that number? I'm just going to change a very small thing. What if I wrote it as 20.0093? I just added a 2 in the beginning. Anybody want to tell me what they're thinking there? How many significant figures would that number have now? John?
Would it be 6?
So John, 6. Okay, I hear another 6 online. So let me see. So I guess you're saying 1, 2, 3, 4, 5, 6. So 2 folks are saying every digit is significant there. Anybody want to counter that or agree with that or give me an explanation for that? Eric? Yeah, so we would have to change the answer if we use scientific notation. Exactly. We couldn't really write this number in scientific notation without changing it, okay? There's another kind of rule that you can depend on here. I'm seeing a sandwich, right? Although there is this decimal point here, guys, I'm still seeing a sandwich. I'm seeing a significant figure here, and I'm seeing a significant figure here. So these zeros in this middle here, despite the decimal point, they're sandwiched, okay? Sandwiched zeros mean that they are significant, okay? All right, so here's what I want us to do. Kind of, if you're following along with me and writing things down, I'm just going to scroll to the bottom here, and I'm just going to write out 5 examples, okay? So at home or on your iPads here in class, I just want you to go ahead and tell me how many significant figures are in the following numbers, okay? So just get a little bit of practice as a group here, and then we'll check these, and then we'll talk about addition and subtraction, multiplication and division. All right, so let me come up with some good examples here. I'll put number 5 over here. Try to put a box around these so I don't confuse you. All right, again, guys, the question that I'm asking about these 5 numbers is how many significant figures do they consist of? And let's come up with one more for you. All right, guys, I'll go ahead and give you a minute or two to work on these 5. And then we'll ask for some volunteers to help me out with figuring this out. Go ahead, John.
Number 2, is that decimal point after the 2, or is that just the 2?
Oh, that's just the 2, honey. Here, let me rewrite it. Yeah, so it's just 82,000. Good question. Do I have enough time? I think. All right. Anybody want to tell me how many significant figures they found in number 1 here? You can type it in the chat. Perfect, Jalen. Jalen says 5. All right, I'm going to write my answers in a different color. I'll write it in pink. Anybody disagree with Jalen? Nope. John says he agrees with you, Jalen. And I agree with you too. So let's prove it. I've got this significant figure and I've got this significant figure. I look at these 3 zeros in the middle. I see that they are definitely sandwiched. Whoops. And so we come up with all digits here are significant because those zeros are sandwiched. We have 5 sig figs. Excellent job, Jalen. Who's got number 2 for me? What are you thinking here?
2.
Excellent. Archie and a couple of my friends in the chat have said 2. All right, so let's prove it. Because I see a lot of zeros here, so let's prove it. Well, I know 8 and 2 are definitely significant because they are non-zero digits. And then I'm looking at these 3 zeros. All right, so they're definitely not sandwiched. And they are not to the right of a decimal point. I don't see a decimal point in this number, okay? So that means that these zeros are placeholders, and therefore they are not significant, so we have 2 sig figs there. Everybody comfortable with that? All right, what about number 3? Number 3 is getting tricky. Okay, Tony said 3. I'm seeing 3 and maybe 4 in the chat. All right, so let's talk about it. Let's first check off the ones that are significant. So the 5 and the 4, for sure, are significant. I'm liking that this 0 is sandwiched here. So that's definitely significant. What can you tell me about this 0 and perhaps this 0?
The other 0 is to the right of the decimal point.
Okay, so this 0 here is to the right of a decimal point. And then somebody, I think it was Jalen, you were speaking as well. What did you say, honey?
I said placeholders.
Okay, Jalen says that both of these zeros are placeholders. John, what were you going to say? Or did they say what you were going to say? Okay, cool. All right, so both of you are correct here. Both of the zeros are actually going to be placeholder zeros. Now that's where things get a little confusing with our to the right of the decimal place, right? So yes, this 0 here is to the right of the decimal place. You're not wrong, it is. However, it is a placeholder 0, okay? So that's where your placeholder kind of rule number 4 trumps that rule of being to the right of the decimal place, okay? John?
So is there like some sort of like PEMDAS for this, like which place one rule is over the rest of them?
There isn't, but I would always say that the placeholder rule trumps any other rule. Yeah. Here's another way of thinking about this question number 3. Let me rewrite it down here just because I wrote all over it up there. And you'll actually start to notice this. Most students start to notice this and actually bring this up to me. Is there anything significant before this 5 here, right? There's nothing significant before this 5. So what that really tells me is that if something is not trailing something significant and is not sandwiched, it's probably not going to be significant, okay? So let me prove to you what I mean. I mean, if I change this number, this is similar to what we did above, but if I change this number to this, okay, or even if I were to change this number to this, now that I have that significant figure on the left-hand side, I'm seeing a sandwich and I'm seeing more significant figures being there, okay? So you can think of those zeros as being significant when they are to the right of a decimal place and trailing something significant, okay? That can kind of be like another, not, you know, it can be an official rule if you want to write that down, but it can kind of be like a check for you, okay? All right, so we will agree, hopefully, that this is 3, and I'm going to label these 2 zeros as our placeholders. And my friends, if you're getting a little confused by this, please don't get frustrated. As we progress through this and go through a bunch of examples, you're going to see the patterns arise, okay? So you're going to be able to say, okay, I definitely I'm applying these rules a lot, so they're going to kind of become a little bit clearer to you guys. All right, let's jump back to number 4, please. What did we say? How many sig figs does question number 4 have, or number 4?
7.
Okay, I have a vote for 7. Anybody digitally want to reply? Okay, Tyler is agreeing and Luke is agreeing. Natalie's agreeing. Okay, beautiful. You've all got it. You've got 7. Let's prove it. So I'm going to check off definitely this number, this number, this number, and this number. Those are all significant. This 0, I'm going to say is sandwiched. This 0 is also sandwiched. And this 0 is also sandwiched. So they are all, in fact, significant. We come up with 7 sig figs there, friends. All right, last but not least, question number 5. John, what do you think?
7 again?
John thinks 7 again.
7.
7.
Jalen agrees. Okay, awesome. You guys have got it. This is 7 as well. I couldn't trick you with all these zeros in the middle, could I? 1 and this 2 are significant, so all of these zeros, that's a big old 0 sandwich. All right, so we've got 7 sig figs there. All right, friends, any clarifying questions that you might have for me right off the bat? Okay. Please don't hesitate to interrupt me if you come up with a question, okay? Especially if you see kind of like a number and you're like, oh, wait, what about this instance? Because that's often, you know, how we learn best here, especially with sig figs. All right, so let's talk about our, we have 2 rules for addition and subtraction and multiplying and dividing. Honestly, we're going to do a lot of multiplying and dividing, you know, past the significant figures kind of learning lesson. All right, so multiplication and division rule is going to become very important to us. Addition and subtraction, it is important, so we do want to keep note of it. Okay, they are 2 different rules here, so you have to be careful, especially when you're doing addition and subtraction and multiplication and division. So for addition and subtraction, this one is probably the you know, weirdest, I would say, if we're kind of ranking them. So when you have an addition or subtraction problem, you're going to round your final answer to the same number of decimal places as the least precise measurement. Okay, so let's break this down a little bit further. Let's look at our example. In this first number, 0.498, I see 3 decimal places. Notice how I haven't said a word about significant figures here. We're only worried about decimal places when we're adding and subtracting, okay? In my 0.34, I see 2 decimal places, right? The 3 and the 4 are past that decimal point. All right, so what's smaller, 2 or 3?
2.
2, okay? So your answer, that means that your answer should only have 2 decimal places. Okay? Now, if you were to type this subtraction into your calculator, I'm going to do it, 0.498 minus 0.34, I get 0.158. So I get 3 numbers after the decimal point, okay? So I have to round here, okay? And that's the whole deal. You're probably going to have to round for most addition and subtraction problems. All right, we'll do a couple more of these on your actual worksheet before I dismiss you. So let's jump into our multiplication and division rule. Multiplication and division rule has sig figs in it, okay? So it's going to connect a little bit easier here. Basically, you are going to round your answer to the same number of sig figs as the component with the fewest sig figs. Okay, so let's look at our numbers here. We've got 22.37. That has 4 sig figs. I hope we would all agree on that. And then 3.10 has 3 sig figs. That 0 is significant because it is trailing the right decimal point and trailing something significant, okay? So my answer should only have 3 sig figs. So I get 69.3 because I have to round a bit, okay? The calculator tells me 69.247. That has 5 sig figs. I got to cut it down to 3. In order to cut it down, I just do a little bit of rounding there with 69.3. Okay? What do we think about these two rules? Do they seem okay? Definitely a little different, but they're not too tricky, I hope.
What was the addition and subtraction rule?
The addition and subtraction rule, Archie, is basically you have to have the same number of decimal places in your answer as the number with the fewest decimal places. So in our example here, we've got this 0.34 has only 2 decimal places versus the 0.498 has 3. So my answer could only have the 2 decimal places. The 0.16 is what we come up with. All right, friends. Any other questions or concerns on the notes here? All right, let's jump into your actual assignment today. I'm just going to go ahead and do like a couple problems with you and make sure directions are clear, and then I'm going to let you guys go. All right. So it is called Sig Figs Practice. Your first section is only stating how many significant figures are in each of the numbers. All right. So I hope that is pretty straightforward. Your second section, section B, is you are going to round to the indicated number of sig figs, okay? So for instance, in number 17, this wants 2 sig figs, so I would end up rounding this to 5.7. All right, so really it's just like a good practice on, well, sig figs, but also rounding, okay? All right, last but not least, we have section C, which is addition and subtraction, okay? Here's what these problems are. They have, done the math for you. The answers are right here, guys. You don't even need your calculator. But what you do need to do is rewrite the answer with the correct number of decimal places, okay? So for instance, in number 26, this first number has 3 decimal places. The second number has 3 decimal places. And my third number has 2 decimal places. So my answer should only have 2 decimal places. So my rewritten answer for this would be 0.29. I have to do a little bit of rounding there. Okay? Everybody clear on how to do that section C there? I know it's a little strange because they like give you the answers and you're like, well, the answers are already there. Your job is to write the answers with the correct number of decimal places there. All right, what about section D? It's the same deal, but now we're doing multiplication and multiplication and division, and your answers aren't given to you. So you're gonna need the calculator unless you wanna do some long multiplying and dividing. So let's just do the first one. When I multiply 23.7 times 3.8 in my calculator, I get 90.06. All right. Oh, it's a good thing that we did this one. This one's wacky. So let's figure out how many significant figures should my answer have. Well, my first number has 3 sig figs, and my second number, 3.8, only has 2. So I can only have 2 significant figures here. So anybody have an idea? How would I write this number with 2 sig figs, John? Aha, John has it figured out. We need, okay, so Luke says 90. You fell into my trap, Luke. I'm so sorry. 90 only has 1 sig fig.
Couldn't you do 90.1?
Oh, could you do 90.1? But Archie,
that would be 3.
That is 3. We're really in a pickle here. Okay, so John did figure it out. He said, what about scientific notation? All right, and here's where things can get a little uncomfortable for us because scientific notation is correct. So I would rewrite this as, I'm going to move my decimal point 1 over. So I would rewrite this as 9.0 times 10 to the 1. All right, Here, let me cross this out just so we're not confused. All right, now you might be saying, but Ms. Link, we dropped that 0.06. You're right. Because my one number, that 3.8, only had 2 sig figs, I can't have all 4 sig figs in my answer, right? It's just not, it's not the rule that we're following here, okay? So there are some instances where you're going to have to do, you know, a bit of rounding in your answers here. All right, shall we just do one more of multiplication and division, since that was a bit of a weird one. In our next, we'll do 41, guys, and then I'll let you go. So we've got 1, 2, 3, 4 sig figs in our first number here, and we've got 2 sig figs in my second number here in this division. So I'm thinking in my head already, I've got only 2 sig figs in my answer. So let's type this in the calculator, or do long division if you're really feeling brave. I get 3.99. Oh my goodness, I get so many decimal places. This is insane. Okay, thank goodness for sig figs, because I don't need all these decimal places. What are we thinking here in terms of rounding? How would I report this number with 2 sig figs the best way possible? John, what are you thinking, honey? Okay, he's thinking 3.9. Anybody have another idea?
I said 4.
Okay, now 4.
4.0.
Ah, yes, Tony, you got it. Perfect, beautiful. She says 4.0. My friends, I would accept either of these answers. Okay, if you're really following your rounding rules really strictly, 4.0 technically is a little bit more accurate, okay, because we've got this whole like 9-5 deal down here. However, I would accept 3.9 as a plausible answer there as well. Okay, guys, any questions or concerns before I dismiss you so you can practice your Siggy Figs? Everybody's okay?
Are you still going to be on the meet after?